Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this video lesson, we're going to be looking at solving boundary value problems. Now, in the last lesson, we had looked at initial value problems using ODE 45, which is kind of our default go-to for stiff equations, ones that aren't solved well by ODE 45. There are things like ODE 23. We're not covering these in this set of lessons, but though there are some other options on that. What I want to do is I want to move to boundary value problems. Now, we had done an initial value problem for this second order equation shown here in our last lesson, and I have added a semicolon at the end of that because I didn't want it to show me everything. It gets sort of old. But so if I do that and I have these two initial conditions, then when I run it, I end up with this as the function solution, okay? And that's all well and good, but what we want to do today is we want to look at what happens if I do boundary conditions. So instead of knowing both the value of the function and the derivative at the starting point, I know values on each endpoint. So to do that, what I'm going to need to do is set up a boundary condition function. To do that, what we're really trying to do is tricking MATLAB into thinking that the boundary conditions at different points are equal to 0. Now, in this case, we've got it so that we have at t equal -1, y is equal to 0. But at t equal to 1, I want y to be a value of 3. And so what we're going to do is we're going to set up this residual so that it is our boundary condition that it finds minus what we wanted. So that'll trick it into thinking that it's 0. Okay? So you need to always set up not just your function, but now also your boundary conditions. And if I want to run that, I also am going to need an initial guess. So my initial guess is going to be my boundary value problem initiation. Okay, so I'm going to initiate it. And I want to go from -1 to 1, right? Those are my limits. And I don't need a particularly fine grid, so I'm going to do a step size of 0.5. You could do finer if you would rather. And then I need to put in an initial guess. So y is 0 and dy dt is -1. And I got that from our previous result, so nothing too special about what I just did there. Okay, so there's my initial guess. Not very meaningful. It just tells me that it's populated this. It's got 5 points, and it's got the first value. Now then I want to run the boundary value problem solution technique. And the function that's built in is BVP, so boundary value problem 4C. And then I name the function, so my function is at second ord. And then I name my boundary conditions. So again, it's an M file, so at BC. And then I need to put in my initial guess that we just created. Okay? And if I do that, okay, it's got an answer. Not very helpful, right? Well, what if we wanted to look at that? So I can very easily say, plot the answer. I want the x's and the y's. And I'll use little dots for my symbols. Okay. And now that I need to find where I hid that graph. Okay. There it is. Notice it goes from -1 to 3. And those are the derivatives. So my first guess wasn't very close. All right. But I was able to solve the boundary value problem. I can, if I want a finer grid, try copy that and put in, say, a 0.1, so I'll get a very fine grid now. All right, and then just going through and repeating all of these steps. And this time my graph, you'll notice that it's a much smoother curve, and we can see that there's a slight wiggle to it, and it does seem to behave like I would have expected a solution to do. So this concludes our lesson on boundary value problems in MATLAB. Thank you very much for your time.